We have 75 cubic centimeters of mercury. This is the atomic symbol for mercury. It's a liquid metal. And the question is, how do you convert this then into grams or mass? All right. What intensive property would you use for converting this into mass? Well, the intensive property that allows you to do this is something called density. Density is the mass of a substance per unit volume of that substance. Cubic centimeters is one of the measures we use for mass. I shouldn't put an equal sign there. I should just maybe have an arrow or something because they're not really equal. But one of the units we can use for, cubic centimeters is volume. Cubic centimeters is volume. Okay, it measures a volume. It's the same size measurement unit as a milliliter. And so we'd have to have some measurement unit on the top here, like grams per cubic centimeter. So density then would allow us to make that conversion. If we had the measurement of mercury in grams per cubic centimeter, we could do that conversion. All right, we'd have X number of grams of mercury over X cubic centimeters of mercury. And using the dimensional analysis that we've been taught in this class, the units of measurement, why don't I write H2? Hg is what it should be. The units and species cancel, and we'd have grams of mercury, and that's what the question is asked about, with the mass of mercury. What intensive property would you use? Where are we? Okay. Now, let's go back and just real quickly explain what an intensive property is. Okay. An intensive property is a property that doesn't change when you change the amount of substance. An intensive property is a property that doesn't change, or a measurement, you could say, of something that doesn't change when you change the amount of that substance. So regardless of the amount of mercury, 75 cubic centimeters could be 75 million cubic centimeters. The density of mercury remains the same as long as temperature and pressure and things like that remain the same. Actually, even pressure doesn't change it much, or temperature. Mercury stays pretty much the same density all the time. It resists a lot of changes in pressure and temperature. A lot of changes in density when you do that. That's why they use it for a lot of measuring instruments. All right? Does that make sense to everybody?